Assalamu alaikum students. Today we will be attempting the paper of the paper number 2025, paper 22. And since as we are doing some selective chapters, so we will do the questions related to those chapters. Those are stoichiometry, rate of reaction, chemical reactions like energetic and equilibria, and the fourth chapter is electrochemistry. So starting from question number 10. The equation for combustion of ethanol is shown. We have this chemical equation. The relative mass MR of ethanol is 46. Which statement about the reaction is correct? So here we need to do some calculations to arrive to the correct answer. So as we know that 46 is the MR value of the ethanol. We need to use the equations and also the calculations to find the correct answer. So let's convert this mass of the ethanol into the mole. For 46 is the MR. So number of moles of ethanol C2H5OH is equal to 4.6 divided by 46. That is equivalent to 0.1. 0.1 is the mole of the ethanol. In a similar way, we have to find the mole for the carbon dioxide. But before that, we must understand how much mass, what is the MR of the carbon dioxide. So MR of carbon dioxide is calculated as 12 for the carbon and 16 times 2 for the oxygen. This is equal to 44. So 44 is the MR of carbon dioxide. So number of moles of carbon dioxide is now at the same time we must understand they are two moles. So this 2 must be multiplied with the MR to get the molar mass. So 88 is the molar mass. Be mindful what's the difference here. For carbon dioxide, 44 is the MR and 88 is the molar mass. There's a difference here. By molar mass, we mean the mass of the respective number of moles. Is if we have 2 moles, that means 44 times 2 will give you 88 as a molar mass, and 44 is the MR. So for number of moles of carbon dioxide, we will write 88, 4.4 divided by 88. So it will be equivalent to 0.05. Now these two are different values. 0.1 and 0.05, they are not same. So that means statement A is incorrect. Now coming to the B part, that says 92 gram of ethanol produces 88 gram of carbon dioxide and 108 gram of the water. So let's validate this option. 92 gram of ethanol. We can easily check how much mole this is. The MR of ethanol is 46, so 92 divided by 46 is equal to 2 moles. And 88 gram of carbon dioxide is basically 88 divided by 44, that's also 2. And about the water, the MR of water is equivalent to MR is equal to 18. So you can do the calculation how much mole this becomes. we would have 108 divided by 18. So 108 divided by 18 is equal to 6. If we consider 2 moles of the ethanol, that means there are 2 moles reacting. And 2 moles of ethanol would also mean 2 must also be multiplied with every other substance. If I am considering 2 moles of ethanol are reacting, that means all the substances should be multiplied with 2. So 2 should be multiplied with ethanol, 2 should also be multiplied with oxygen. That would give you 6 moles of O2. And 2 multiplied with CO2 would give you 4 moles of CO2. And 2 times of 3 will give you 6 moles of the water. So you need to do the calculations accordingly. We got correct amount of the water, but with respect to the carbon dioxide, it's not correct because 4 moles of carbon dioxide is not equal to 88 grams. Rather, it would be 88 times 2, which is equal to 176. So carbon dioxide mass should be 176 instead of the 88 grams. We have decided this by considering 92 gram because 92 gram was equivalent to 2 mole. So this indicates that B is also not the correct option. B is also wrong. Then C part. C part says 138 gram of ethanol reacts. So let's see how much this becomes in terms of mole. So 138 divided by the MR of the ethanol, which we know is 46. Now this is equivalent to 3 moles. If you consider 3 moles, I have to raise over here. If you consider 3 moles for the ethanol, that would also mean all the other substances must also be multiplied with 3 times. They are uh, comparing with oxygen. The oxygen should also be three times of 3. 3 is already there. So 3 times 3 will give me 9 moles of O2. But here you can see 32 gram is not equivalent to 9 moles of O2. Instead, it's just a mass of 1 mole of O2. For just 1 mole of O2, the mass is equal to 32 grams. So that's also incorrect. Then we check the D option. In the D option, it says 184 gram of ethanol. So 184 is equivalent to 4 moles. 184 divided by 46 is equivalent to 4 moles of ethanol. Now, if it is 4 mole, you need to multiply the whole equation with 4. So, if we multiply the whole equation with 4, we need also compare with the water. So, 4 mole of ethanol would mean 4 times of 3. That is equal to 12 moles of the water. And we know a mass of 1 mole of water is equal to 18. So, multiply this thing with 12. So, 12 times 18 is equal to 216. And this is exactly the value here. So that says D is the correct option. So this is correct option. I hope it's clear to everyone. Then next question, 11. A compound has this percentage of carbon, this percent of hydrogen, and this percent of oxygen. Its MR value is provided. find both empirical and molecular formula. So we have been doing similar type of questions in your practice. So we will apply the same steps. First of all you need to do is to convert these masses into their respective moles because percentage also means the mass. So carbon ratio, hydrogen ratio, oxygen. The carbon mass is in the question is 40%. That means 40 gram. Hydrogen mass is 6.5%, which means 6.7 gram, and oxygen mass is 53.3. Now convert these values into the moles, which means we need to divide with their respective AR values. For carbon, we know it's 12. For hydrogen, is 1. For oxygen, is 16. Now, if you do the calculation, this value will be equal to 3.33. This value will remain as such, 6.7. And 3.3 would also give you 3.33. So these are the moles calculated. Now the next step is to determine or to calculate the simplest mole ratio. Simplest mole ratio is the next step. For that purpose, you have to divide all the values with the smallest value. Here, 3.33 is considered the smallest value. So divide all these three values with 3.33. So you will get 1 ratio 2 ratio 1. That means the empirical formula of this compound will become CH2O. This is the empirical formula, CH2O. We select CH2O from here. The next part is to also find the molecular formula. And we remember these steps involved in molecular formula determination. First of all, you find the value of N, which is a multiplier that is equivalent to molecular mass divided by empirical formula mass. The MR is given, which is 60, and empirical formula mass for this will be 12 plus 2 plus 16 equals to 30. So 30 the empirical formula mass. Its value is equal to 2. So multiply this 2 with the empirical formula CH2O, and it is now equal to C2H4 and O2. So C2H4 and O2 is the only option in the molecular formula column. That means B is the correct option. Then question number 12. Question 12. Hydrogen oxygen fuel cells are used in electric cars. Three statements about these fuels are listed. The process in the cell is called electrolysis. Which statement are correct? So the process in the cell is called electrolysis. Basically, it's a technical question. Although we remember there were the construction of the fuel cell like that of the electrodes. If you come to the notes uh, of my O level, this is the information related to the hydrogen oxygen fuel cells. We know within the hydrogen oxygen fuel cell, we have the negative electrode, positive electrode, the electrolyte is there, and there are also the production of the electrons. That means the production of the electricity. So you will be thinking this hydrogen oxygen fuel cell is working as a electrolysis because in electrolysis we have similar construction of electrodes and electrolyte. But the thing is here, there is a basically combustion reaction. The hydrogen is being combusted with the oxygen. Oxygen is reacting with the hydrogen, and you are providing both of these fuels. You are providing both the hydrogen as well as the oxygen to the fuel cell. So there is formation of the water as a product. So you do not say it's an electrolysis. It's not electrolysis. Rather, it's the combustion. It is a combustion, but combustion is providing the electricity. That's what it is happening here. Combustion of hydrogen is providing you the electricity to run your electric car. So this is the process. This is the principle behind the working of hydrogen oxygen fuel cell. So that's why A option is incorrect. Then B option says water is broken down in the cell to produce hydrogen, oxygen, and electricity. So if we again look at the uh, literature of hydrogen oxygen fuel cell, we do not see the uh, breaking down of the water to make hydrogen and oxygen. Rather, it's the opposite. It is not from water to hydrogen oxygen. Instead, it is from hydrogen and oxygen towards water. The correct diagram or the correct direction is from left to right. Combustion of hydrogen to make water. So it's not the decomposition of water into hydrogen and oxygen. That's why the second statement is also incorrect. Then comes the third. The third option says the third option says it is water is the only chemical product formed in the chemical reaction. So yes, as we saw before, the reaction is basically H2 plus O2 reacting together to make H2O. So H2O is a product, the only product here. So that's why third statement is correct. So it means the correct option is D. I hope it's clear to everyone.
Yes, sir.
All right. Then question 13. A solution of copper sulfate can be electrolyzed using copper electrodes or carbon electrodes. Which statements are correct? So if you remember from the previous paper of first variant, we did discuss the same question, but only in terms of the in terms of the copper electrodes, not in terms of carbon electrode. But here in this question, they have included both type of the electrodes, copper electrode as well as carbon electrodes. So if I take you to the topic of the electrolysis of copper sulfate using both the carbon electrode and copper electrode, we remember that using the copper electrode at cathode, which is a negatively charged electrode, there is a deposition of copper ions to convert into the copper metal. So copper metal is produced on the cathode, and at anode there is a formation of the copper plus two ions, which is the positive electrode. But in case of the carbon as electrodes, mind it, carbon and graphite both are same thing. Inert carbon or inert graphite both are same thing. So in case of the carbon electrodes, there is a formation of the copper metal at the cathode, the negative electrode, and at anode, there is a formation of the oxygen gas at anode. So we have to verify the statements in the question. First statement says using copper electrodes, oxygen gas forms at the anode. So that is a wrong statement because what we saw in the copper electrodes, there is a formation of the copper plus two ions at anode, not the oxygen gas. In case of copper electrodes, again, the copper atoms lose electrons at the anode. So yes, if we have the copper electrode, then copper atom will lose electrons at the anode to form copper plus two ions. Loss of electron means formation of copper plus two ions. That is correct statement. And at anode, we remember it's the oxidation reaction, that is loss of electron. The third statement says that using carbon electrodes, copper metal forms at the cathode. So yes, that's what we learned in the case of carbon electrode, or that also the graphite, because both are carbon. So there will be formation of copper metal. And the fourth option says using carbon electrodes, copper ions gain electrodes at the cathode. So yes, that's the same thing. Reduction. Like reduction means gain of electrons. So copper ions, which are Cu plus two, gain electrons and they convert into the copper metal at cathode. So both this option is also correct. This statement is also correct. So two, three, four statements are correct, which means option C is the correct option. Now, question number 14. Question 14 has a very special case here. There will be some difference in the calculation. So I will urge all of you to do the calculations along with me so that you can cross check your answer at the same time, because there will be some difference of answer in the calculation as compared to the mark scheme. The question says the equation for the combustion of hydrazine is given, and we have the bond energy values. Keep your calculators ready with you so that you can do the calculation. What is the overall enthalpy change of the combustion of 1 mole of hydrazine? So if you remember from the notes, that delta energy enthalpy change is basically delta E, or delta H. It's a delta H enthalpy change. And you basically have to find this value, for which the easy formula which I told you before, delta H is equal to bonds broken minus bonds formed. It's the simplest formula which you can learn. And bonds broken are done for the reactants, whereas bonds formed are done for the products. Well, bonds are formed in the products. Now you have to do the calculation of the energies, bond energies of the reactants as well as for the products. In the reactant, we have this molecule which is hydrazine N2H4, and this is a displayed formula of hydrazine. So use this display formula to find the value of the hydrazine molecule. We can see that in this hydrazine we have one bond of nitrogen to nitrogen, which is a double covalent bond. So double covalent bond value is 409. So I'm writing the reactant values separately. This is equivalent to 409 over here, plus the value of nitrogen to hydrogen, which are in total 4 bonds. There are 4 bonds of nitrogen to hydrogen, single covalent bond. And in this table, we have 391. So you have to multiply 391 with 4. So 391 times 4 plus oxygen O2. And its value is given in the table as 496. So 496. Now add all these values, because this is the value for the reactant. So in my calculation, the answer which I am getting is equivalent to 2469. I hope you are all getting the same thing. 2469. If there is any difference, please let me know. I have selected all the bond energies from this table accordingly. So if I suppose you are also getting 2469 as a value of the reactants. Then come to the bond energy value of the products. So in the product side, we have N2 molecule. This is N2, nitrogen triple covalent bond, nitrogen. I will use red color for the product side. So N2 is equivalent to 944. So 944 plus we have two water molecules here. This is H2O. So in one H2O, we have two bonds of OH and we have 2 moles of water, which means we have 4 times of the OH bonds. So OH bond is given 463, so multiply this value with 4. So we have 4 times of 463. The value of this side is equivalent to 2796. 2796. I hope you are all also getting the same value. If there is any difference of value, please tell me. Okay, no one has given any other value. So we now use this formula to find the enthalpy change. That means delta H is equal to bonds broken, which is equal to 2469 minus this value 2796. What's the answer you are getting? Yes, students. What's your answer? Minus 300. Check it again. 2469. Okay, fine. 327. Right. So it is 327. Fine. I did miscalculation before. So minus 327. So A is a correct option. Question number 15. Dissolving ammonium chloride in water is an endothermic change. Which row shows the energy change and temperature change of the mixture during the dissolving of ammonium chloride? So it says direction is of the endothermic change. So we will be applying the concept of temperature change related to the endothermic. So we remember in the endothermic change there is a cooling process. There is a cooling effect in the endothermic reaction. So by cooling we means a drop in temperature. So that is a decrease in the temperature. So temperature decreases in the endothermic, and with respect to the energy change, endothermic means absorption of energy. Energy is absorbed in endothermic. You have already studied this thing from the literature. So energy is absorbed in the endothermic. That means option A is a correct option. Then question 16. Aqueous sodium thiosulfate reacts with dilute hydrochloric acid to form a yellow precipitate of sulfur. The precipitate forms more quickly when the reactants are heated. Which statement explains this observation? So, increasing the temperature by heating forms the reaction quicker or quickly. So, what it would mean here? First statement says the reacting particles collide more frequently. So, yes, the frequency of the collision depends upon temperature. Temperature is related with the frequency of collision. So if you increase the temperature, the particles will collide more frequently. So statement one is correct. The second statement, the collision between the reacting particles have more energy. So that is also correct. Temperature was directly related with the kinetic energy of the collecting particles. So if you increase the temperature, then kinetic energy of the particle will also increase. That's why second statement is also correct. The third statement says the activation energy of the reaction is lower. So let's understand this point by looking at the reaction profile diagram. In the reaction profile diagram, we learned that using the catalyst basically reduces the activation energy. First of all, what is the activation energy? You should remember it is the difference of energy from the level of reactants to the top of the peak, both for the exothermic as well as the endothermic reaction. It's the difference from reactants level to the top of the peak. Now, the effect of using the catalyst. So for this purpose, I will show you the notes of the retro reaction. In the use of the catalyst over here, we remember that it basically lowers down the peak of the reaction. That would mean the activation energy is decreased by the use of the catalyst. A catalyst lowers the activation energy of the reaction. So we can now apply this concept on the question. The question says the activation energy of the reaction is lowered by heating. So that is incorrect. Activation energy is lowered by the catalyst, not by the heating. So first and second statements are correct. So the correct option is A. I hope it's clear.
Yes, yes.
Then, all right. Then question number 17. Which statement about the conditions used in the Haber process and in the contact process is correct? The typical pressure used in the Haber process is similar to that used in the contact process. So if we have to verify this thing, we have to check the conditions from the literature. So according to the literature, we we see that the pressure associated with the Haber process is equal to 200 atmosphere. This is for the Haber process. And for the contact process, the pressure is equivalent to 1 atm or 2 atm. A pressure of 1 or 2 atm is required for the contact process. 2 to 3 atm, in some cases it says 2 to 3 atm, and in some cases it writes 1 to 2 atm. Or in other words, it's just a range of 1 to 3 atm. But for Haber process, it is equivalent to 200 atm. So it's a quite large difference of almost 100 times. So A is incorrect. The pressures are not same. Then B says the typical temperature used in the Haber process is similar to that in the contact process. So that is so. If we look at the temperature, so Haber process temperature is 450 degrees centigrade, which is also equivalent to the temperature required in the contact process of 450 degrees centigrade. So both are similar. So B is correct option. Even then, we can validate the other options. C says the Haber process uses a vanadium oxide catalyst, and the contact process uses an iron catalyst. So that is a reverse case. Vanadium oxide is used in the contact process, and iron catalyst is used in the Haber process. That is a reverse case. So the C is incorrect, and D says both process produce an acidic gas. So that is wrong. Haber process produces the ammonia gas. And we remember ammonia is basically the basic gas. It's not the acidic gas. Ammonia is the basic gas, and for contact, we do get the acidic gas because it forms the sulfur trioxide, which is an oxide of the non-metal. So this is acidic gas. Ammonia is the basic gas. So D is incorrect. Then question number 18. The equation shows the equilibrium between dinitrogen oxide and nitrogen dioxide. The forward reaction is endothermic. Which statement is not correct? At equilibrium, the concentration of the reactant and the product stay constant. Yes, equilibrium has this property. The concentration remains the same. They do not change. At equilibrium, so statement is correct, but that's not the correct option. At equilibrium, the rate of the forward is equal to the rate of reverse acceleration. That is also correct statement. Then C, when the pressure is increased, a darker brown color is seen. So according to the equation, we have 1 mole of the reactant and 2 moles of the product. So increasing the pressure would move the equilibrium towards that side which have the lower number of moles, lower number of moles by increasing the pressure. And here, the less number of moles are on the reactant side. So basically, by increasing the pressure, the equilibrium should shift towards the left direction. The equilibrium shift should be on the left direction, and on the left direction, it is a colorless gas that is produced. It's not the darker brown gas because darker brown gas belongs to NO2. So this statement is incorrect because increasing pressure should shift the equilibrium towards the left side, towards the right side. So the C statement is incorrect, but the option is correct because we want to find the incorrect statement. And the D option says when the temperature is increased, a darker brown color is seen. That is correct because the reaction is endothermic. And we remember that if we increase the temperature of an equilibrium, then the reaction shift towards that side that is of endothermic side. Increasing temperature shift toward endothermic. So towards endothermic is the product side, which is the brown gas. So that is seen here. A darker brown color is seen by increasing the temperature. So D is also the correct statement, but option is incorrect. Then the last question, what is the oxidation number of chromium in the Cr2O72 minus? So do the simple calculation. There is -2 charge for 7 atoms of oxygen. So -2 times 7 gives you -14. The overall charge is 2 minus, which means the plus charge on the chromium should be +12. The +12 is for 2 atoms. So for 1 atom of chromium divided with 2, that gives you +6. So +6 is the correct option C. So in this way, we have also finished the related questions, relevant questions of this paper, the second variant of October November 2025. If you have any question, please let me know. And in the next class, we will be attempting the third variant of this exam series.